put it inside a copper pipe, and I'm going to drop it. Does anyone have any predictions? What's going to happen here?
Slow the pipe.
I hear a couple of ones slow down, ones stay the same. Well, okay. Let's compare it here. It rings a little bit, but it doesn't really slow down that much. So that's not at all interesting. What I have here are just a couple of rare earth magnets stuck together. These are pretty simple magnets, actually. The thing that distinguishes them from the magnets you're used to seeing, the big U magnets or something like that, are the ferrite magnets that have been around, well, the Romans first investigated them. The only difference between these and those is that these are just a little bit stronger. Don't ask me what elements are actually in these, I can't remember. But if you were to open up your hard drive, computer hard drive, you pull out things like this. Same type of material. It's just a regular magnet, only stronger. So I'll start my control here. I'm going to drop it in air. There's no real difference. It's because gravity and magnetism are two completely separate forces. They don't interact at all. I'm going to take it. I'm going to drop through here. Any guesses this time as to what's going to happen? No, it's the same.
Let's go through.
Oh, that was neat. Now, maybe you don't believe me. Maybe you think it's just bouncing off the sides, and well, if you want later, we can try it and we can look and see. It is actually just falling still. The only thing that's happening is it's falling a lot slower inside the copper pipe than the steel bolt here. Now, the difference between the steel bolt and this, besides what they're made of and all that, I mean, all things fall at the same rate anyway. The only difference is that this isn't magnetic, or at least not appreciably magnetic. This has a magnetic field. So what this is an example of is it's actually an example of one physical thing, induction, but it's got about 3 different names depending on when the book you read was written. And since most of the ones you read were written in the last 100 years, it's usually called electromagnetic induction. It's also called Lenz's law, where if you have a moving magnetic field, falling, or any moving magnet that doesn't be falling, you create an opposing magnetic field in nearby conductors that tries to oppose that motion. And the best way to do it is put it in a tube. So you create a current, basically dropping this through the tube, creates this current that winds around as it falls, and circulating current like this creates an opposing magnetic field in the other direction. You want to use the right hand properly. That's what's happening. It's moving magnetic field, creating a current which opposes the motion. So that's, it's neat actually. It's sort of something you think, oh, well, that makes sense, but it's just cool. This is generators in a nutshell. How to build a generator. Right now I have circulating currents running through a continuous copper pipe, and this is just regular copper, by the way. Someone asked me that last time. It creates currents running through the pipe, and as it falls, it just creates more currents as it goes. If you wanted to make this useful and generate electricity with this, though, you want to harness those currents, take the pipe, stretch it into a wire, and then wrap it around again. Basically take wire, wrap it around in just the right direction, let it fall through, and this time those circulating currents will run through the wire instead of just running around in circles, and you hook that up over here to something, a light bulb, a transformer, power grid, and you get power. And that's actually how all generators work, except now instead of having it running through tubes, we reorient it, we run spindles and rotors and generate electricity that way, but it's the same concept. Moving magnetic field creates an electric current, which in turn creates an opposing magnetic field. So it's neat, it's a cool demo, and it explains some real world phenomena that are actually very, very important, because this is how all of our electricity is generated.